In this video, I'd like to discuss solving rational equations. Here's how this is different from what we've been doing before. Up until now in these videos, we've been simplifying rational expressions through addition, subtraction, multiplication, and division. When you simplify an expression, this may seem obvious, but there's no equals sign. You're simply rewriting this expression in another form, but it has the same value as what came before. So simplifying an expression is rewriting it in lowest terms. If I take this expression with no equal sign and I'm told to simplify it, it just means I rewrite it, in this case, by combining it as a single fraction in lowest terms. That's different than solving an equation. So we often skip over these words, but they mean something important. We're looking for something different. To solve an equation means to find the value or values for x that make this whole equation true. So when I'm done with this problem, I should have something like x equals -2 or x equals 5. When I'm done with this problem, I have a simplified expression that still has variables in it, that still has coefficients in it, it's just in lowest terms. So there's a real difference between solving an equation and simplifying an expression. Let's pay careful attention to that all through algebra. Here's our strategy for solving rational equations. We can multiply both sides of the equation by the least common denominator and solve the simplified equation. Multiplying by the LCD allows us to divide out all of the denominators in our fractions, and we get a single line with x in it that we can solve using rules of operations. We also need to check for extraneous solutions. So extraneous solutions are a value for x that would cause any of the expressions in the original equation to be undefined. Remember that these rational expressions are undefined when the denominator equals 0. So in this case, if x equals -2, this denominator will be undefined. That means I can't accept as a solution for this equation x equals -2. If I would do all the algebra and it leads to that solution, x equals -2, I have to reject it. It's an extraneous solution. It's not even in the domain of these expressions, and I would just say there is no solution to the equation. Let's look at a couple examples of solving rational equations. For my first example, the denominators of the fractions are exactly the same, x plus 2. So that is the least common denominator. Now we keep equations balanced by performing the same operation on both sides. So we're going to multiply both sides of this equation, the left side and the right side, by the LCD, which is x plus 2. What this means is each of these terms are going to be multiplied by x plus 2 as this distributes to everything inside parentheses. And it's going to multiply into the numerator of these little fractions. So I have 2x times x plus 2 over x plus 2. And here I have -3 times x plus 2. And here I have -2 times x plus 2 over x plus 2. But what does it do in these fractions? We can simply divide the common factors here. And then I have the simple equation 2x minus, let's distribute this 3, so we'll say -3x minus 6 equals -2. Just like that, there are no fractions left in our equation, and we can simply solve for x by combining like terms. So here I have -x, 2x minus 3x is -x, -x minus 6 equals -2. So when I finish solving this, I get -x equals +4, multiplied by -1, and we get x equals -4. That's our solution to this equation. This is not an extraneous solution because as we look at these original denominators, only the value x equals -2 is undefined in these denominators. So if I plug this in, these denominators are not equal to 0, and the whole equation is a true equation. We always need to make that check at the end. Here's another example. And in this case, I want to factor this denominator before we get started, just so I can identify the LCD of all of these denominators. This denominator factors as x plus 5, x plus 2. It's helpful to know that because those are the same factors that I see repeated over here. So the LCD is simply x plus 5, x plus 2. Now this can get cumbersome to write out, but I'm going to perform the same operation or use the same strategy on the second equation that I used on the first. I'm going to multiply all of the terms on both sides by the LCD, and it's going to multiply into the numerator in each case. So let's see if we can sketch this out. The first term is 9 times x plus 5 times x plus 2 over that same denominator, x plus 5, x plus 2. This is going to be 5 times x plus 5, x plus 2 over x plus 2. And we're going to be subtracting another term, minus 3 times x plus 5, x plus 2 over x plus 5. Let's think about what divides out of each of these fractions and what remains. So with the first part, with the left side, all of these factors divide out. We just have the number 9. So I'm rewriting this simple equation here. 9 on the left side equals, the first term here, x plus 2 divides as a common factor, and I get 5 times x plus 5. I'm going to write that as 5x plus 25. Then we're subtracting this term. And here, x plus 5 divides out, and what's left is minus 3 times x plus 2. When I work that out by distributing the negative 3, I have minus 3x minus 6. So this is our simpler equation now. There are no fractions left. We can solve this equation for x very quickly. So 9 equals 5x minus 3x is 2x. 25 minus 6 is 19. Let's subtract 19 from both sides, and we get negative 10 equals 2x. And divide by 2, we get x equals negative 5. Now we need to take a minute to think about this. X equals negative 5. Can we accept that as a solution? In this case, the answer is no, because when we look at these denominators, if I plug negative 5 in here, I get a denominator of 0. This is undefined. So this is an extraneous solution. It appeared to work out through the algebra, but it actually creates an undefined mess when we try to plug it in for x in the original equation. We have to reject this, and because there are no other options for x, we're going to say there is no solution to this equation. There's no value of x that will solve the above equation.